Greetings and welcome to episode 47 of the Sustaining the Herd podcast, brought to you by Setchi Agri-Services and Engineering of Raymond, Nebraska. I'm your host, Andrew Wadle, and I'm joined in the studio as usual with my co-host, Brock Vitek.
Hey there, Andrew.
How you doing, Brock? And hey, we're also joined in the studio today with our very special guest, Jared Burma from Bristola.
Hello. Thanks for having me.
Thanks for joining us, Jared. And before you get to know Jared, and Jared talks about his story and his businesses, just a couple things. We want to welcome everybody back to Sustaining the Herd. We really appreciate the feedback we get from our past listeners, or our current listeners, and we welcome all of our new listeners as well. And for our new listeners, just a little bit about Sustaining the Herd and what sustainability means to Setchi Agri-Services and Engineering. And generally what we talk about is all topics related to sustainability, particularly related to animal agriculture. And so, when our view of sustainability kind of has three, it's the proverbial three-legged stool. The first is protecting the air and the water, protecting the air we breathe and the water that we drink, and keeping any contaminants or pollutants from impairing those things. And really, air and water is the interface between society and animal ag. So that's number one. Number two is resource efficiency. Doing more with less is a really important part of sustainability. And really, recycling is part of doing more with less. And we know that agriculture it's the greatest recycling system the planet has ever known. And then the last part is business sustainability. And it's sustainability more like the softer side of sustainability, and it's the people. We need to have good, strong agribusinesses with people working safely. And that's really going to be a big part of what we talk about today. We all want to have good, strong agribusinesses, and we want to have the people that are working in our agribusinesses all go home to their families and loved ones every night. And so strong businesses, every aspect of that is a huge part of sustainability. So that's a little bit about sustaining the herd. So with that, Jared, tell us just a little bit about you.
Yeah, thanks, guys. Again, I'm Jared Burma, CEO of Bristola. So I've been in the water treatment, cleaning industry for my entire life. I think 26 years now. That's the only thing I've ever known. Started out in basically the traditional style of cleaning, where you're dredging and trucking, land applying, and doing all that all across the United States for municipalities and different entities. And then, had a time where we were cleaning out a tank and the sediment wall fell in on us, and got the guys out safe, and made it my mission since then to find a different way to clean tanks, a better, a safer, more economic, more sustainable way to be able to clean these tanks. And so fast forward to today, we're running a company called Bristola. We have quite a few different clients out there across the world and grow them constantly. So excited to share some more details about that today. Excellent.
Well, Jared, thanks for sharing a little about yourself and the inspiration and why you do what you do today. So I'm just curious. I know that Bristola is your main business, but upon doing some research prior to the episode, Andrew and I found that you've also gotten into the grain handling space as well. Could you just give us an intro to that part of your business too?
Very exciting. We literally just pulled the curtain off that last week at the Jeeps show down in Kansas City. Basically, that came about. A couple of my buddies from a large co-op decided they were getting out of the public sector, the big corporations, and wanted to do something different. Knew what I was doing at Bristola, sat down in a room and said, why aren't we doing this with grain? And grew up in my family farms, and the worst job I ever did, I remember it to a T, was July, August, getting in grain bins, keeping my foot on the sweep so it keeps moving around the grain bin, and using a shovel to shovel corn into that. I'm like, and they're like, yeah, now think about that on a scale of a 200 diameter grain bin or 7 million bushel grain bin. And these companies got to follow these new OSHA rules, 1 in, 1 out, whole watch. All these guys are like, we deal with this on a day to day. We got to figure out a different way to do that. And so I was like, well, we already have the platform. I mean, we have ROVs running in the toughest environment known to mankind, bottom of manure tanks and oil and gas tanks. So like, why can't we just take that platform and utilize it in the grain world? And so we set out on a mission, unveiled it last week, and the response has been overwhelming. It's been a whirlwind of good things, and then really of emotions. Met a lot of people that have had loved ones die. Wasn't ready for that conversation. Like I knew it happened, but I didn't know how close we were going to be to it at this grain show. And matter of fact, a couple of the companies came up to us while we were there, and they just had one of their big clients had passed away in Kansas the day before the show in a grain bin. And it's just been eye-opening, which is why I got into the liquid side, but I didn't even put two and two together about the grain side until recently. So.
Yeah, it's fantastic because, just as I kind of alluded to the fact that agriculture is the greatest example of recycling the world has ever known. It's agriculture in terms of superlatives is also one of the most dangerous occupations the world has ever known. And so kind of gives give the impression between digesters and tanks, and whether it's grain tanks or manure tanks, you're kind of like the confined space specialists in some way.
Well, I don't know about you guys, but my objective is to not go in any of those confined spaces. I've spent a lot of my years of my life inside of those, and so I have a soft place in my heart for putting people in there because I was the guy in there, whether it was grain or liquid or sludge or whatever. And so anything I can do to keep my staff and anybody else's staff out of there. Now, I understand there is going to be times it's just got to happen. I get it. I'm not saying it's a end-all, be-all, but if we can improve and eliminate it at least 95% of the way, I guess that's why I'm here today. So,
yeah. Well, that's awesome. So can you just describe... Well, first of all our listeners need to know that the videos that you can see online are absolutely amazing. But can you just go through just what the Bristola process is?
Yeah.
Let's start with an anaerobic digester, okay. So a liquid slurry tank, and then we can get into the grain side of things. Let's just start with the anaerobic digester.
Yeah. So funny. It's best to start with the anaerobic digester because I get made fun of all the time. Why would you have picked the hardest environment to start in? I mean, an anaerobic digester is literally I'm preaching to the choir, but maybe if people out there don't know, it's super sensitive. We hear all the time, one guy can run a whole plant, no problem. I mean, but digesters are very, very sensitive. They got to have the time and the heat, and they got to do all this stuff. And it's a biology masterpiece going on in there. And when anything upsets that apple cart, things start going south really quick. Well, what we found over the course of time was people don't want to clean their digesters or liquid tanks out for a couple different reasons. Was because one, cows don't stop pooping. People don't stop pooping. Things have to keep going. You can't interrupt the system. Well, most companies and or municipalities or whatever industries don't build extra assets on their property just to sit empty for when we got to clean them so we have a place to go. And so, being sustainable, we don't want to waste a bunch of money building extra tanks because we got to have a place to clean them. And so we found that that's one of the reasons. The other reason was simply because of the hazards of going in these tanks and the challenges and the confined space and the liabilities that all arise out of that. So what we did is me and my team figured out a way to basically be able to put we call it an isolation valve, but it's basically a bidirectional gate valve on the manhole of an existing tank or a brand new tank. That's the only thing that stays there. And so the client owns the gate valve. The gate valve stays on their manhole. It's installed. It doesn't move. It acts like a second blind, cover on their manhole.
And what's the diameter of that, Jared? Sorry to interrupt you, but just to give people a sense of the scale. What's the diameter of that?
The minimum diameter is what we'll do is a 24-inch manhole with an ID of 23 and a quarter minimum. And then we'll go up to a 36-inch manhole or larger as well. And so that's the little bit of the gray area. However, if you kind of check out some of the different scenarios, a manhole has to be a certain requirement because a human has to physically be able to fit through it. So there is other size holes on tanks, but technically they're not considered a manhole if they're smaller than that because humans couldn't physically get in and out of it, so it's not a manhole. And so we figured out that size, that's a common size, and where we needed to be, and the minimum diameter we could get through. And then we went from there. The client would call us, and what we developed was a lot of companies have ROVs, but we've developed ours a little bit differently. But the bread and butter of Bristola is our entry box. So that entry box will hook up to that gate valve. We equal the pressure inside that box with a preloaded ROV to the pressure of the tank. And then we turn the valve open, and there's no fluid exchange, no movement. And so then we can insert the ROV into the tank using lots of different sensors, and a lot of technology goes into it. But then we can lower that ROV to any level. So we talked about the tanks out in Nebraska, they're built below grade. But we can lower that ROV to any depth, or it can go straight in and go to work. So we have a lot of different technology working. And then the beautiful thing about that box is it allows a hose to come out the back end, hooked to the ROV, so the ROV can traverse the bottom of the tank, removing the sediment, send it out to a separation system. We separate in real time the solids out of it and put the liquid back in the tank, so the volume of the tank never goes below a certain level. What we found over the last 3 years is we'll keep that digester operating at about 80 to 88% efficiency while we're cleaning it. So they're going to lose a little bit just because we're bringing the volume down a little bit, but if you do the math, when you drain it and you clean it the traditional way, you're 100% down. So that 88% really will offset the cost of cleaning out that digester, to a degree. But that's kind of the brains behind the Bristola system.
Right, and so just the way I would characterize your entry box, I kind of think of it as it's almost like a submarine lock,
Yep.
when you see divers go out of a submarine. I'm saying this just so our guests can kind of visualize this. So the vehicle is in there, you open a gate, and then the vehicle crawls, drives, is driven remotely into the tank.
Yep. We've had some other people compare it to the NASA. Like when you're in space, you don't just walk into the space, what's the word I'm looking for? The space station. So when you dock, you have to equal the pressures inside the space station to where you're at before you can transition from one atmosphere to the other. And that's all we're doing. We're equaling the atmosphere on the outside to the inside. So when we transition in the inside, there's no huge fluid exchange or movement of that tank.
Gotcha.
Jared, thanks for describing the Bristola process for us. But I'm curious now whether or not a person's using Bristola or a typical, drain the tank and physically clean it out. What is a typical clean out sequence or timing in a regular maintenance schedule for an anaerobic digester plant?
Oh, isn't that the $1 million question? Yeah, I mean, so our system, and this is where we have to go back and forth with a lot of people, is our system's designed to be a maintenance system. So you really, we know within a day of when we start running out of good material or the tank's clean enough that we should move on, and we never shoot to get 100% out. We just want to keep you in that good fighting range all the time. So we try to tell our clients the first time you get the valve on, within the first 6 to 8 months, we should come do a cleaning, see what's in there, kind of getting a feel for how things are running, what's going on. We have clients that are year 3 and we still haven't been there yet. It's they're kind of trying to compare us to a traditional cleaning, whereas they want to let 10 foot get in there and see huge problems on their back end and then have us come do it, where we're trying to get away from that. So, we, on sand bedded dairy, we're seeing, even with a great sand separation system at the front end, which a lot of people don't have, they're getting 2 to 3 foot of buildup a year. So we should be there every 8, 10, 12 months minimum. Now, we get this all the time. Well, we don't have sand, so we only need you once every 3 years. And we've been to a couple of those now, and they have 12 foot of sediment in there. And the economics of using our system when you get to that level starts to drop rapidly. You got to understand we're 24 inches wide, and you have to pay for technology and no man entry and all this stuff. And the economics start really, they start oh my gosh, what? I didn't think it was going to be that expensive. And we're like, well, if you waited more, 2 more years to do a traditional clean out, you're losing all your production. Your gas is going to drop, your volatile solid reduction is going to go down, your pathogens and all these things are going to change, and things are going to go out the window, and your performance overall is going to drop dramatically. Then you're going to still have to pay to take it offline, clean it, and put it back online, reseed it, and do all this stuff. And that's a constant discussion that we have internally, and like trying to get people to maybe change the gear of thinking to do it as a more maintenance versus a emergency, or it's like a complete and utter disaster cleaning. And so I can't tell you, the exact answer to that, but we do have the ability to come in for a day or two. And if you're not getting a lot of solids, because you'll know, within the first deployment, that ROV goes in and our sensors stop at a certain level. We know we're on top of solids. And okay, you only have a foot in there. It's not really that big a deal. We can clean some and get out of here. Or we go in and it drops and stops right away. Oh man, you have 10 foot of solids in here. We have a big problem. We got to clean a lot on here. And so there's ways to kind of understand that, but there's just not a great way to know that prior to us getting there. I think there's some technologies coming down the pipeline to be able to measure effectively sediment buildup in a tank, not going in through the top, not a FLIR gun, not like that. Now, it's a little pricey right now, but we're kind of exploring that as well, just because you just don't get that reading and or knowledge of, I only have a foot in here, unless we're there and you're paying us, or you're just guessing. And so that's kind of where we're at right now.
What about temperature on the outside of the tank? Like if it's sand's built up or whatever's built up, would you have a temperature differential,
Yeah, that's that FLIR gun I was talking about. And so, you can do that. However, a lot of the tanks we're finding are getting built 7-8 foot below grade. Well, the FLIR gun doesn't work below grade. And you're like, well, it's warm at grade, but what's 8 foot below grade? And so if the tank's built on flat ground and it's up and you can have a FLIR gun, you can get a pretty good idea of what's in there. But it's the ones that aren't at grade and above that we have in the hard time of kind of understanding where we're at.
So when you go and do a clean out, what are the things that you find? We know that there's sand, because everyone blames everything on sand, kind of like how house fires are always blamed on the electrician, even though the plumber has a torch, Yeah. What do you find when you go into a tank?
So this has been a very big learning curve for me over the past 5 years. And so, technology is great until it's not, right? And things are great until they're not. But when I came from the traditional world, so you always drain the tank, then you get in there and you look at the solids, all right? And you understand it. So, but what I didn't understand was for about every foot of hard, non-organic sediment, there could be up to a 3x factor of what they call a sludge blanket, which is still rotten, nasty, can change your pH in a matter of seconds, that's sitting on top of that sediment. That when you drain, it will flush out with you. And so you don't technically see it when you're going to do a traditional clean out. I've cleaned this tank out 100 times and we only ever have 3 foot. Well, yeah, kind of. But what did you just pull out of there that was sitting on top of that prior to us to come to clean the heavy sediment sitting there? So what we found is when we go into a live tank completely full, in operation making gas, our first couple days are pulling that sludge blanket and we get just hammered on, well, you're not getting any sand. Like, okay, but I can't tell you what your sludge blanket is, what's coming to us, because you got to understand 20 PSI is a lot of pressure. It's going to find the easiest path of resistance out of there. And we're giving it a path, with head pressure. And so that sludge blanket will move and migrate to us and you start working, and then you get into the sand and start doing that. So the biggest learning curve for me was taking into account that sludge blanket that exists. No matter, anybody can argue with me all day long, but I'm physically seeing it. I've talked to hundreds of people about this, chemical engineers, biological engineers, chemical engineers, and they all agree that there's always going to be a sludge layer. Now, could it be an inch or could it be 3 foot? Like every layer in every tank will be a little bit different, but there always will be a sludge layer and then the sediment layer. And so that was new to me, because come from a traditional world, you just drain it and just go right at it, and you don't really see the layers that happen inside of a tank. And so that's probably the biggest thing I've taken away from there, that people just, it's really hard to wrap your head around. But at the end of the day, it's still very, very beneficial to get that sludge layer out of there. And it's not sand. It has nothing to do with sand. So that's kind of a new thing for me.
Yep. Well, it's and when it comes right down to it, it's really it's elementary, particle dynamics, because a small dense particle settles the same as a large not dense particle or less dense particle.
Well, I learned something already. Look at that. See, I don't know.
or some of that organic matter we would call wannabe sand because it settles, right? It that blanket formed because I mean it's still heavier than water.
Amen. Yep.
So anyway, but
everything.
Absolutely, cracked corn kernels. You know, a waterlogged or turd-logged corn kernel. You know, it's going to settle. It's going to settle right there beside a fine sand particle.
Yep.
So we were talking a bit online that there seems to be a misconception that, hey, I didn't bed with sand. Where's all this grit coming from? You know,
right.
That's probably quite an eye opener for some people.
It is. I mean, it's a battle. It's almost a battle just because they think that we're just pulling out liquid and in a fiber. You know, like everybody wants to see sand come out and nobody wants to see this. And I call it rotten fiber. But if you hold it and like you look at what they're separating on the farm, their bedding that they're going to reuse, and versus what we're taking out, and you just smell it, you can tell the difference almost instantly. Like, you don't want to bed on that stuff, guys. That is not, there's something wrong. You know, the pH of that stuff is different than what you want to use on your bedding. And so, yeah, it's a constant uphill battle for us just to educate, because at the end of the day, you can't see with your own two eyes inside the tank and watch what's happening. That, you know, it's always like, if I can't see it, I just can't wrap my head and or believe it. And so that's where we've been the last few years, but we're getting there. We're making progress, showing people a lot of different things and a lot of different testimonials and white papers and all that kind of stuff.
So one of the biggest takeaways here to me is, you know, and this falls under the category of absolutely any process, any mechanical process, any machine, and that is, this is a maintenance process. Yeah. It's not a repair process, and you don't want it to become a repair process, right? Yeah. You want to maintain your car before it fails. You want to maintain your digester before it fails, right?
Yep.
So what do you do if you're what I'm going to call your traditional access box? What do you call the access box again? The
entry box.
Entry box. Okay, so let's just say your robot is in the entry box. You open the 24-inch gate valve, and there is just a wall of sand. I'm sure it's happened a time or two. What's the remedy to that?
It's almost so if we're taking percentages, it's happened 80% of the time on our cleanouts so far. Whoa. Yeah, because they're like, oh, we just traditional clean this out. We don't need to worry about this. We're 3 foot off the floor. There's no way we have 5 foot. 83, I think, % of our cleanings doors have been plugged. And we know that because nothing comes out and you have 40 foot of head above you and there's nothing coming out. Well, it's a couple different things. One, I have to educate the client, is now we become way less efficient because we have other steps that we have to do. We have a jetter head that we can hook up to our arm. Basically, when that happens, we close the valve, open the lid, put our jetter head in, and then basically open it back up, and we run high pressure jetter, and just basically we'll auger that hole out until we get fluid moving through it, get the fluid out. Then we use the ROV with a horizontal head going in to eat itself in. Then we take it back out, and what we developed 2 years ago is called a vertical hole digger. So if that floor is 10 foot below grade or 10 foot below the manhole, we know we have 8 foot to get to the bottom. It's not efficient for that ROV to sit on the top of that sand and try to work its tracks back and forth to get down. So we put vertical digging augers, and then that goes in. And so we have to change out 3 different times. And that's a process because you got to depressure the box, take the lid off, take the ROV out, put this in. And so it becomes very inefficient from how many cubic yards did you remove to get to the floor at that point. And so that's where the challenge comes.
Mm-hmm. Yeah, it really sounds like, it's, maybe this is a poor analogy, but get your oil changed every 5,000 miles instead of needing a rebuild every 50,000, right? It's kind of no different. If you're not on top of this maintenance, it becomes a much, much bigger issue.
Can I jump in on that real quick? Because this is it's great that you brought that up, because this is my point I tell everybody. If I could change your oil while you're driving, taking your kids to school, and you didn't know I was under there, would you do it more often?
Mm-hmm.
And they every single time. Well, yeah, it's just a pain to pull in. I gotta wait. I gotta get my oil changed. It's usually not so much about cost. It's about my time, and I have to do this, and I gotta do that. And the digester world's no different. I don't want to shut down and stop making gas, so I'm gonna kick this can down the road as far as I can. Well, if I tell you I can clean this while you're making gas, what's your pushback? Then it's like, oh, well, yeah, that changes the game a little bit. So I always tell everybody, if you could get your oil changed driving down the road, and you would never even know we're there just to pay the bill at the end, and you just keep moving and no interference of your day-to-day, every single person would do it, because they're like, well, that would be dumb to let it go until it blows up when I don't have to even waste 1 minute of my day or change anything about my day to get my oil changed. And so that's kind of what we use. And so it's funny that you brought that up, because we use that a lot. So yeah.
Perfect. I'm glad that worked out. Jared, I'd just like to ask, I'm sure you see literally everything. I'm sure it spans the gamut as far as stories you could tell of what you guys have found in digesters, or maybe grain systems as well now. But what can AD developers and designers of grain storage systems be doing to ensure success? What are some of the hard lessons that you've learned or seen others learn that people should be writing down as they're looking to design and build projects?
Yeah, and I'll just jump onto that. I'll just jump into that and say, and it could be any, if you could just, because you see things that others don't see. If you could answer that question from the standpoint of all aspects of digest, not just cleaning, but what do you see that could help people be more successful in designing digester systems?
100%. And I've been asked this quite a few times, so I have an answer at the tip of my tongue. Simplicity. I've seen so many complex, convoluted things inside of a tank that absolutely blows my mind. Like, it's like, what did you think was going to happen technology is great until it's not. And so I asked the people, like, okay, you're going to put all this inside your digester. What happens when it stops working? And they're like, oh, it won't fail. Well, hold on. There's nothing in the world 100%. I've yet to come across that's 100%. So anything that can fail or has any moving piece will eventually fail, especially in the toughest environment known to mankind, with manure and gas and all these things corroding on it all day long, every day. So simple inside, simple outside. It's you gotta simplify the process. People are, I've seen tanks where you grid pipe all these different gas pipes running in and along the floors and stuff. I'm like, well, it works great for 2 years, but then what? If something breaks, and then what are we gonna do? I think I had the count last year. I think I've seen 110 different designs. So, at any business, and this is where I get frustrated in the AD business, is about standardization. How can we not just standardize the tank, the process, and be done with it and replicate it time over time over time? Europeans are getting much better at that than what we are. They've got a few years ahead of us on the digesters, but it seems like every farm I go to, it's different. It might be the same brand of digester, but then it's different, and it's different, and it's different, and it's different, and you're like, guys, why? Oh, my farm's just different. Well, it's not really. And if you can standardize things, parts get cheaper, maintenance gets cheaper, operation efficiency goes up, because now we know it's the exact same thing over and over. It'd be like if Ford, every single thing they did was different on the truck platform, SUV platform, everything. Like, no, they have a lot of standardized things that they just do day over day over day, because they know they work. And I think that's my biggest thing, is simplify and standardize it. That's the biggest thing I can say at this point.
So would you advocate for external heat exchangers? Have you ever seen heating on the walls? I don't mean I'm gonna take on the floor, out of the equation. Yeah. Heating on the walls. Have you ever seen that be successful?
Yeah. Okay. I mean, it can be. Again, I've seen a lot of this stuff be successful, but only until it's not successful. And it's about a numbers game. So are we talking successful for 20 years? Or are we talking successful for 2 years? And or what I always pose the question back to the client is, I learned this, and it's kind of weird, but you always got to plan for the divorce or the disaster. You know what I mean? Like, yes, everything's great until it's not. So when it breaks, then what do we do? What are you going to do? Well, it's brand new. I don't want to think about that. Well, that's the problem, is because it could happen tomorrow or it could happen 10 years from now. But heating in the walls is great until a pipe bursts or breaks. Heating on the inside of the wall is great until sand or H2S or something pops or something breaks, and now we got to drain the tank to fix it. And then the heating on the outside of the wall is great until you're in Canada and it's 9,000 below zero and we can't maintain the temperature of our tank. And so pros and cons to everything, but I think you can still standardize that in some way, shape, or form to say, okay, every digester should be built with this, and that way every single person has the ability to get this part and replace it, and then we know it's this much time. I maybe be shooting for the stars, but I think that's where we got to go to make the industry super efficient, everybody makes money, and everybody has a lot of uptime.
It also brings the cost down.
Amen.
I would describe what you've. I would summarize what you just described as the reason there's so many changes is because people are still figuring it out.
Yep.
and so it is a classic case of evolution and adaptation.
Right.
And so that having been said, we sure need to be getting a little bit better with every single. If we just need to make sure we're not going backwards.
I think I tell my kids, if you can just get 0.5% better every single day and not repeat the same mistake twice, by the end of the 20 years, you're going to be operating at the 100%, and it's hard. I get it, and everything's different. So I'm not raining on anything parade out there, but I get called when it's a disaster and everything fails, and I've seen it over and over and over. So that was my 2 cents.
Yeah, and so and so Brock asked the question as related to anaerobic digesters. How can they improve? We've not given the grain aspect of this, the grain handling aspect of this, enough credit, because that's a huge thing. And as we talked about, it's a place where a lot of people get hurt.
Yep.
And it's a miserable job. I'm in my mind, I can see young Jared in the grain bin with his foot on the auger, and wearing a little paper respirator if he was lucky.
Yep.
What do you do in? Give folks a sense for what you do in, say, a grain bin.
And so in my life, I've never been the one to make a lot of friends. So probably some people might get irritated with this, but the grain sweep is great until it breaks. I think there's a sweep out there for a liquid tank, and great until it breaks. And this is every single client that came up to us, large, I'm talking Fortune 500 companies, were like, our grain sweeps are great, but they only, a couple years, and then all of a sudden we have 7 million bushels of corn on them and they won't work because they're broke. Now what do you do? Like, again, it goes back to everything that can break will break at some point. It's always going to happen. It's just there's nothing in life that's 100%. So I took the same mentality at this. Simplify it. Maybe, I'm not saying don't use a sweep. I know there's going to be a lot of people like, well, you can't compete with a grain sweep. I get it. Grain sweeps are very expensive, though, in the realm of large moving grain sweeps. Very, very expensive. And then we still have to go in and clean because they don't get to the edges, they don't get all of it, blah, blah, blah. And then what happens when they break? And so this was designed to be able to get in either after a sweep, in replace of a sweep, or when a sweep breaks. And so the simpler you make your bin design, meaning the floor, the sweep, the edges, like they're just don't overcomplicate it inside that grain bin. The same thing I say for the digester, because if you do, we can't help you. And then now you have to go in with guys to get that done. And it's very, very challenging, very dangerous environment when you replicate that time over time.
So with call it the sweep failure scenario, is it the same kind of deal where you have a port and the unit crawls in and empties the tank?
No, so it's a little bit different. So basically, at that scenario, the sweep fails. You can either just use the grain vac with the door on the outside, or the existing leg that's in there, until you get it to concave enough. And so then at that point, you basically are just pulling that door open, and you can let grain come onto the ground and vac it up as it's falling. But basically, the biggest thing is you get the door off, and then there's ramps that you drive the ROV in with the hose and vac all hooked up, and then you can operate the ROV from your pickup. We designed it so back in the day when I was doing this, I'd have to jump out, move the semi forward, jump back in, try to make sure I'm racing the clock on, is the semi full, looking out the door, is it overloaded? I designed this around, can I sit in my semi, listen to a radio, eat a sandwich, look in my rearview mirror while removing grain, pull my semi ahead, when it's full, hit the button, shut my grain vac and everything off, go ahead and leave, go to the elevator, come back, fire it all back up. That's how it was designed. That was the concept behind it. And that's where I designed it basically so one person can be safe all the time. He's not in there by himself, because we all know there's farmers out there stretched for labor, stretched for time. They're going to just go do it by themselves. You get stuck in there by yourself, there's nobody coming to save you for a few hours, and that's the bad part of the deal. So
not a good deal at all.
Yeah,
you're done.
Mm-hmm. Well, Jared, as we start to wrap things up here, you know, you shared some good lessons learned about keeping things simple. Any final words for all of our designer and developer friends on any further recommendations for success before we close it out here?
Nope. Not really, but at the end of the day, just the closing is, I get it. Like Andrew said, we're still evolving, still changing. I'm not saying one system's any better than the next. I hope to 5 years from now, we all sit down and have another one of these talks and say, look at this, everybody's doing pretty much the same thing and it's all working, and we know exactly what it's going to cost. We know how much it's going to build. We know the maintenance parts. We know these guys have it on the shelf, and we can keep these things running very effective and efficient. Because I really believe, AD is a great asset when utilized properly. I think it can do great things, but we still have some evolutions to go through, I think.
And I just have one more question too, as we kind of close out. So, is there any merit to a scenario where the Bristola system is just like the pool cleaner that kind of is always crawling around all day long? Is that part? Could that ever be part of the model?
It's on the horizon. It's funny that So okay, by the end of the year, we will be able to run our system from our office in Des Moines anywhere in the world. And so we'll send one guy to hook it up. He'll sit in the truck from a sheer safety standpoint, and we'll have our team in here running it so the guys can be home at night. We don't have to pay motels and per diem and travel, and they're not missing their families. And we have one guy on site versus 3 or 4 guys. And then the next evolution of that is then it's got to get economical enough to where we can just leave it on the tank. When it's time to run it, they call, we open it up and rock and roll. And it's definitely in the works. Yep.
That's awesome. I think that's a great. I'm thrilled that that's your end state, because that takes the whole someone running the car to 50,000 miles, without an oil change off the table.
Yep. Amen.
You guys are innovating and evolving, and we love to hear it.
Yeah, appreciate the
time. Thanks so much for choosing to spend some time with us today, Jared. It's been a fun conversation, and I'm really confident our listeners will find it equally exciting.
And Jared, how can folks get a hold of you? Because we just think this is really good, and we'd love for you to get some access to some people who are in need of this technology.
Absolutely. So you can find us at Bristola, Bristola, the number 2.com for all of our liquid stuff. And there's a button on there to get to our grain side too, and vice versa, or Burma, Burma, then capital AG, Ag.com, and that's our grain side. So and they're both interlinked, and so you can find either or from either side. So
outstanding. Great. You heard it here, listeners. Go to Jared's website, get a hold of him if you'd like to. And with that, I want to say thank you to all of our listeners, both new and returning, for choosing to spend some time with Jared and Andrew and myself today. We've really enjoyed the conversation and hope that you have too. And we look forward to being back with you again with a new episode in a couple of weeks. Until then, thanks for joining the herd today.